students, so let us see surface tension. Okay, so molecules, okay, this surface tension is nothing but force per unit length. In simple terms, if we say, suppose this is surface of water or surface of any liquid, surface of any liquid, surface. So if we take, okay, a bucket, here this is what is surface, this is what is surface, this is called the bulk, this is called the bulk, this is surface. So there will be molecules on surface also, there will be molecules in the bulk also. So if we take a bucket of water and if you are dipping hand inside, so inside that inner area, that is nothing but bulk. Okay, on the surface, okay, if I am touching, this is surface. Are you able to feel the water? So this is surface, this is bulk. So the molecules in bulk will have some difference in terms of energy, okay, compared to the surface. Okay, now there are two forces happens here, two forces. Okay, one is cohesion, okay, number two is adhesion. So the attraction between same molecules, okay, this is what is cohesion, and attraction between different molecules is what is adhesion. So water, the attraction between water molecules, that is what is one example for cohesion. And if you take a mug of water and if you throw on, what will happen? Here water will be there. So why water is sticking here? Force of adhesion. When I am writing, this stick is this ink is sticking on this whiteboard, example of adhesion. Correct? These are the examples. Suppose this force of cohesion for mercury is very high. Suppose if we have mercury here, if I take a mug of mercury and if I throw, this will not stick here. Just like if I am throwing a ball, it will come down, right? It will bounce back. Same way mercury will come down. Then after that, just like you have seen all Terminator movie, having seen? No? Arnold Schwarzenegger's Terminator movie is there. In that, that villain character, even after shooting so many times, or even if he bomb or fire, whatever it may be, if he melts, after that what will happen? It will come together and again he will start running. Then they are not humans. The movie itself is portraying this as not human. Okay, so that is how mercury. So force of cohesion, force of adhesion. Now surface tension, suppose if this is this bucket and water, this is the top view. Okay, top. So same way, if we take the top view, top view, this is that liquid or water. Suppose if we draw an imaginary line here, if we draw imaginary line here with the length L, the force here to both sides, no? Okay, suppose even if you draw the line in this way also, there will be force on both the sides. So this force per unit length is what is surface tension. This is either denoted as S or it is denoted as T. Clear? This is a simple definition of surface tension. Clear? If you take a painting brush, painting brush will be just very smooth. Simply it will be like this. Okay, it will be separated. Clear? If you dip inside water or paint, after that if you take it up, what will happen? It will be together. It will be sticking together. Okay, that is because of surface tension. Okay, this is because of surface tension. Clear? Fine. So this is a simple idea, simple definition of surface tension. So its unit is nothing but Newton per meter. Dimensional formula of surface tension will be mlt raised to minus 2 divided by L. Correct? Force divided by length. L if we cancel, m t raised to minus 2. Correct or what? Okay, done. Okay, so this is what is surface tension. Clear? Now, the factors which affect surface tension. One example is, one point is actually impurity. See, because surface tension of water cannot get into every molecules or every small areas of anything. Suppose if we take a fabric, if we take a cloth, water cannot reach everywhere. Okay, even if water reaches also, the force of cohesion between the water molecules will prevent it from taking action. Suppose if we add impurity, okay, an impurity which decreases the surface tension of water. Okay, so certain people, they did some work to identify material which can decrease surface tension, and they came up with detergents or soaps. So when you mix water with the detergent or soap, what will happen? It will get into, surface tension of water will come down. What is happening here? Surface tension of water will come down. So suppose if we three are water molecules, me, Bala, Shabari. Shabari wants to go behind that camera, he wants to do something there and come. But because of force of cohesion between us, this Bala and me, we won't allow Shabari to go there. Hello, understood or what? So water molecules wants to go inside, Shabari wants to go, but we won't allow because of cohesion. Stand here, attraction, too much of friendship. Then fortunately some impurity came in between. Some 3 molecules extra came. Those people are quarrelsome. Between us, it affected our force of attraction. Okay, that is what is this detergent or impurity. what happened? The force of attraction, the bonding reduced. Now this time Shabari doesn't have any fear. Even if SK says also, I will go. Bala, move ahead. I want to go. Shabari will go. He will play. So in that thing, what will come out? Dirt will come out of the fabric. Understood or what? Okay, so dirt will come out. So this is the system. Impurity, if we add, it will decrease the surface tension. Example is detergent, soap that we use. Okay, another factor which affects surface tension is temperature. Okay, so if we increase the temperature, again what will happen? Surface tension will decrease. So if you want to clean the clothes that much, okay, too much dirty, then make hot water, then detergent, double effect. Okay, it will remove the dirt much better way. So increasing the temperature will reduce the surface tension. Clear? That is also there. Now what happens is, because of surface tension on the surface, because of this strong attraction between the molecules, this side, everywhere attraction, so this will act like a elastic membrane. This will act like a elastic membrane. So because of this reason, you could see insects walk on the surface of water. Have you seen? Mosquitoes, they walk on the surface of water. Simply they can move. Correct? We will be able to see that the small legs is making small dimple there. Correct or what? Small legs of mosquito will be making small dimples there. Okay, and you might have seen the elastic membrane like thing, stretchable elastic membrane like this, where kids will be jumping. Not only kids, even adults can also jump. Okay, so jumping to the height, this elastic membrane will go up. Correct or what? So how strong that elastic membrane, that much jumping we can do. Correct or what? Suppose if that elastic membrane is weak, what will happen? Him once jump, he will go to the earth. He may not come back. Correct or what? So how strong that elastic membrane is, in that way they can do the jumping. Same thing, same effect will happen here also. How strong the surface tension, these insects will be able to move around it very peacefully. Correct or what? So this will act like a elastic membrane, so that insects walk on that. Clear or what? Okay, so just for your understanding, just to get a feel of that. Suppose if you take a small ring or something, and if you dip inside soap solution, and if we take it out, we will get a soap film. Correct or what? We will be getting a soap film. So suppose if this is the ring, and we have soap ring. What is soap film? Okay, this is soap film. Okay, soap film. soft film. So this soft film, suppose if I take, okay, just like this is a small, okay, this kind of a toy, small thing. Somewhere we have gone for seeing any kondatam, some festival, something, then we will be seeing someone is doing like this, okay, soft bubble making, all that. There we got something like if we will be able to make soft film, something like that, very simple toy. So we have taken this, is it there on the board? No, it is in my hands. Okay, now if I dip in the soft film, I have taken back. Okay, now I can see this side one surface, this side another surface. Correct or what? So you should remember this. This film has got two surfaces. The thing is, all these surface tension are acting only on the surface. So our main focus will be on the surface. If we take a bucket of water, on the top of it, surface is there. Surface is there. How many surface is there? Only one surface. Only one surface is with air. Only one surface is in contact with the air. So if I take a layer of film, this side, this layer is made of one molecule. One molecule, all are one molecule or what? Or there can be many molecules. There can be many molecules. So we need not think like already one surface we have counted about this molecule. Same molecules backside again we need to count or what? Okay, Shibin, SK. This is also SK only. Correct or what? This is not two SKs, right? Correct or what? Okay, but if we have cloned and if we have made two SKs, this is one SK, this is second SK. Correct or what? Okay, same, one Shabiri, another Shabiri. One Bala, another Bala. So if I take this one, I could see here molecules on this surface. If I look like this, this is molecules on the second surface. So two surfaces will be there. If we understand like this, things will be easy. Otherwise, always this will irritate us. Why two surface? Okay. If we take a bucket of water, there is only one surface. There is only one surface. Okay. Water drop. How many surfaces will be there? I am making all these fundamentals now itself, so that later you will not be under trouble. Otherwise, this will be full of doubts. Okay, why is it taking two surfaces here? So water drop, you take water drop. How many surfaces? One surface. Only one surface is in touch with the air. Inside full water. If we get into the water drop, glue, 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 glue. If we go out of the water drop, fine, able to breathe. So only one surface is in touch with the water drop. What about soap bubble? If we take a soap bubble, how many surfaces are there? Two. Inside air, outside air. We blow it and it will go, no? Okay, so if it is full of water inside the bubble, pling, it will go down, right? So inside air, outside air. Keep it in mind. Okay, this is how we should calculate the surface. Okay, surface. Clear? Done? So write those points in your own language, taking those examples. Okay, if you do not know, please take those examples. Done? Okay, one question. Water in a beaker of radius 5 centimeter. Okay, find the force exerted. Find the force exerted, okay, by one side of water of diameter on surface on other side of water of diameter. Okay, surface tension is given as 0.075 Newton per meter. So water is taken in a beaker of radius 5 centimeter. Okay, so the radius is 5 centimeter. Find the force exerted by one side of water of diameter. Okay, find the force exerted on one side of water of a diameter, okay, on the other side of the water of diameter. Okay, so that is the force exerted on the other side, okay, on this side. Okay, this is nothing but just a question of surface tension. So take like this, how much force will be there? This, if this is 5 centimeter, this is going to be 10 centimeter. Surface tension is already given 0.075. So this is equal to force by length. So 0.075 is equal to force divided by 10 centimeter. So force is equal to 0.075 into 10 raised to minus 2. Bas. Clear or what? Done. Clear? Okay pa children, understood? Okay, another question is, this is a soft film. Its surface tension is given as, this is a soft film. Its surface tension is given as 0.03 Newton per meter. Clear? This length is 10 centimeter. This length is 10 centimeter. Now we are dropping a small mass here. Okay, we are dropping a small mass here. What is the amount of mass, okay, if this is in equilibrium? What is the mass if this is in equilibrium? What is the mass if this is in equilibrium? Yes, what is the answer, children? Okay, so here mg is equal to surface tension into this length. Anything else I should add? Into 2, correct? No? Into 2. Two surfaces will be there. This is a film. So two surfaces will be there. Clear or what? Now we need to find mass. M is equal to 0.03 into length is 10 into 10 raised to minus 2 into 2 divided by 10. Okay. So what will be getting? 6 into minus 4. Okay. Done. Clear. Okay, now we need to see certain cases where pin, ring, disc, if we put in water, okay, and if they are floating on the water and if they are in touch with the water, what will happen? Force will be acting on it, okay, because of surface tension. So we should understand that how much force is acting, okay, for each cases. Okay, so that is what we will see one by one. So this is easy explanation. Okay, say for example, if a needle, okay, like this, if it is on water, okay, if this is on water, what will happen? Both the surfaces are here, both the surfaces are there. Suppose if we take like this, one end of needle cross section, if we consider like this, this is also there, this is also there, correct or what? So I will be here two sides, so that surface tension into L, here also surface tension into L. The length of the needle, if we consider as L. Correct or what? Understood? Please see this. Any doubt? Correct? So along with this, what also will act? Mg also will act. Okay, so if a needle is sticking to the thing in the water, okay, just like a mosquito leg, it is able to walk. Okay, so what is there? Mg will be there. At the same time, how much it is in touch with the fluid. So there also surface tension also will act on it. Surface tension also will act on it. So surface tension is nothing but surface tension into force is nothing but for surface tension into length. Correct or what? So this side, if I consider, suppose if this pen is the needle or pin, then this side also will be in touch, this side also will be in touch. Correct or what? So minimum force to take it out, minimum force to take it out will be equal to 2TL plus mg. Correct or what? Okay, not that point. Number 1. Minimum force required to take it out. What is the excess force? Already mg is there. Because of surface tension, excess force will be how much? Excess force is 2TL apart from mg. Clear or what?
So it is lying on the water or it's standing like this?
Lying like this.
Lying on.
Number 2. Suppose a ring like this, okay, another ring, and this area, okay, suppose if its radius is r1 This radius is R2. This radius is R1. The other radius is R2. We are interested in the length. Correct or what? Force per length is what? Is surface tension. So we will be looking at the length. So here this length is actually 2 pi R1 and this length is nothing but 2 pi R2. Correct or what? Okay. Okay. This is a ring. This is a ring like this. Okay. How it is kept? It is kept flat on the water. This is the ring. Inner it is hollow. So inner radius, okay, this side it is flat, something is there. Outer side R2, 2 pi R2, inner side 2 pi R. Understood or what? This is not hollow, this is hollow. Clear? Understood the concept? Okay, so what will be the excess force? What will be the excess force? This length 2 pi R1 into surface tension plus this length 2 pi R2 into surface tension. Bus over. Okay, clear? Now instead of having this is big ring, Leah. This is big ring. Okay, big ring like this. Okay, now small ring. Small ring if we take. Okay, inga light chinnada. Okay, just to show there is some thickness but very negligible, very small thickness, just to show this is a ring. Just like முன்னோர்கள் வளைகள் போட்டுட்டு இருந்தாங்கல்ல, our ancestors used to wear bangles, no, கையில. Correct or what? Wala, bangle. Nowadays that is not there. No one has that, right? Boys or girls, no one is wearing, right? Correct? இருக்கா யாருக்காவது? இன்னைக்கு கிளாஸ்ல யாருக்காவது வளை இருக்குதா? பேங்கிள் இருக்கா? ஓ இருக்கு. ஓ இல்லைன்னு சொல்லியிருந்தா சொல்லியிருக்கலாம், இருந்தா சாக்லேட் வாங்கி கொடுத்துருப்பேன்னு சொல்லிட்டு. இருக்குது இல்லை? So this is radius pa children, just this is radius. So இது ரொம்ப சின்னதா இருந்தாலும், even though this is also will create force, this side also will create force. Instead of F is equal to 2 pi R1 into T, what we will write? 2 pi R into T in the side. This side again what? 2 pi R into T. It's your wish. If you want, you can write 4 pi R into T. No need to by heart. Understand the formula, understand the system and study. When you prepare for the exam, I told you now, no need to go through all the derivations and waste time. Understand formula, what is this all from the figure. But this thing, please understand how this comes, so that it will be easy for to remember. Clear or what? Okay. A disc with the radius R. A disc with the radius R. Okay. Now what I am writing is all excess force. Okay, excess force due to surface tension. To take it out, mg plus surface tension. Okay. Ipo either Rajas and Ranis, what is the extra force here? 2 pi r into L plus 2 pi r into 2 pi r into T plus 2 pi r into T thane idum illayo. Then what? 2 pi r into T. Good. Understood, Mukesh? All of you? Purila? Okay, done? Fine. So all these are problems actually. Okay, they will ask these problems. What we will do? For us these are all direct, no? Next thing, we'll discuss about surface energy. So surface tension is what? The force of attraction. Okay, suppose if we take a soft film, and if from this t-shirt I am taking a thread and I just threw. So when I threw, this thread went like this, correct or what? Then I took a pin വെച്ചിട്ട് കുത്തുമ്പോൾ it will be paining, no? Pin. From pin, using pin I just prick here. Okay, so what will happen? Before, this force all were equal. So this was not at all varied, continuing in this shape, nothing was there. Now what happened? When this was soft film, it was like this. When we pricked, what happened? The inner side soft film was not there. Now what will happen? From every side force will be only in the outer direction, no force towards the inner direction. So what happens? This will take a circular loop, circular shape. Okay, circular shape. Clear or what? Fine. Right. Now another thing of surface tension is the liquid drops are spherical in shape, because using this process, because of this attraction, it will try to reduce the area. More explanation will come when we discuss this. It will try to reduce the area. Minimum area possible for a volume will be sphere. If we take a volume of 1 liter water, if we using 1 liter water, if we want we can make square, if we want we can make rectangle, if we want we can make cylinder or sphere or whatever it may be. But the shape which will have minimum area, the least area, is sphere. So that is the reason all these drops will take the shape of the sphere. Clear? Fine. Now come to surface energy. Surface energy is an energy possessed by the surface molecules. In simple terms, what we can say is, if we take some water, okay, or any fluid, this surface will have the molecules. This is surface molecule, and this is bulk. So this is surface molecule. So the energy associated with the surface is what is surface energy. What happens is, when if we take a bulk molecule, what will happen? This will have force of attraction in all the directions. But if we consider a surface molecule, it will have attraction in the downward direction. Get up. எழுந்திரிங்க. Okay, don't sleep in the class, get up. Okay, அப்போ அவர் தூங்கிட்டு இருந்தவர் எந்திரிச்சிட்டிங்களா? Now if I look at him or her, people will understand now who is sleeping. Got up or what? பரவாயில்ல, got up. எப்படி? யாருக்குமே தெரியாது யார் தூங்கிட்டு இருந்தேன்னு. ஆனால் தூங்கிட்டு இருந்த ஆளுக்கு மட்டும், எனக்கும் மட்டும்தான் தெரியும் யார் தூங்கிட்டு இருந்தேன்னு. only that gentleman and me, only we to know that who are sleeping. செம்மையாக இருக்குல்ல? ஏன்னா உங்களோட மானத்துக்கு எந்த பிரச்சனையும் இல்லாமல் I will deal it, don't worry. Okay, only intention is okay, fresh, no? Done. So அவரோட ஃப்ரெண்டுக்கும் புரிஞ்சிருக்கும் போல. Right, so nothing wrong. தூங்குறது நான் அவ்வளோ தப்பா? All night maybe studying, no, that is why. Only thing is the biggest punishment is for students தான். கொஞ்சம் எட்டி பார்த்து இருந்துச்சுன்னா 2 years debar. Correct or what? If we write no, somehow we need to pass. Maybe teacher might not be teaching well also, but mistakes with many people, no? The system of the school, system of the college, teachers taking pain and teaching, definitely it will benefit us. But if they are not working and teaching us, definitely we are the scapegoats. So எப்படியாவது பாஸ் பண்ணலாம். Okay, then we will be taking something, and if we are copying, mistake only, fine, mistake only, but punishment, what they will do? 2 years debar. Okay, but people who kills, no, and stealing crores of money, they will be moving around. So students தப்பு பண்ணக்கூடாது. Students தப்பு பண்ணிச்சுன்னா மிஸ்டேக், நம்ம தூங்கக்கூடாது, எதுவும் பண்ணக்கூடாது. ஓகே, அவ்வளோதான். Look children, so what will happen here? This molecule will be having the downward motion. So this will come. இங்கே வந்து ஹால் போட்டுட்டு இருக்க முடியாது இல்லை, அங்கே ஒரு ஹால்னு போட்டு இருந்ததுன்னா எல்லாருமே இங்கே வந்துட்டு இருக்கும். Entire thing will not have molecules. That will not happen. This full volume will have occupied, right? So if it comes, what will happen? So okay, இந்த molecule ஒரு பேர் சொல்லுங்க. ஏ எல்லாம் வேண்டாம், ஏன்னு சொல்ல யாரு? Anita. No one is there, no Anita in the class. Her name is Anita. Women empowerment. Okay, first name for lady. Then what is its name? Prabha. Prabhaso. Prabha. One sweet girl is there in the class. Deeban போட்டுக்கலாம். Okay, Deepa. So Anita, people were pulling Anita, come Anita. So Anita came here. So meanwhile what happened? Okay, Deepa, this is a nalla avasaram, this is a good chance. So Deepa went there. Okay, so Deepa thought I can sit there. What happened? Madhumati, there is another. So what happened is this is also again attracting. So Deepa cannot continue there. Okay, so there was another molecule, its name is Madhumati. Okay, so this Madhumati went there. Madhumati went there and occupied that slot. So what happens? All the surface molecules will be keep on coming, other molecules will be keep on going, coming going. This is going to be in always in motion. Always these molecules will be in motion. So another important thing is, when Anita lost the chance for Madhumati to reach here, who is Madhumati? Molecule. மறந்துடாதீங்க. Don't forget. Finally, Deepa, Anita, Madhumati will be remembered. These are all molecules. So Madhumati needs to go there. Okay. Is it possible for Madhumati to simply go and sit there? Madhumati will have to do work. Madhumati will have to do work. So Mg is there, attraction is there. So dealing all of them, then only Madhumati reached here. So for molecules to reach the surface, it will have to do what? Work. This work is stored as surface energy. This work is stored as surface energy. Clear or what? So this work is stored as surface energy. So these water molecules will not be at peace. சாந்தியே இருக்காது, நிம்மதியே இருக்காது. எனக்கு அதிகமா மேல அடையணும், நிறைய பணம் வேணும், பதவிகள் வேணும்னு சொல்லிட்டு all these water molecules will be trying to go to the surface. Everyone will be fighting, everyone will be backbiting, bringing them up. Again it is going, okay, always in motion, always in motion. So this surface energy is the energy associated with the surface, and when the molecules, when it goes to the surface, when it go to the surface, it will have to do a work. That work will be stored as surface energy. In order for a molecule to come from infinity to this point, what do you say? Potential. So work done per unit charge is a potential. Simply the work for the mass to come to this point is what is stored as potential energy. The charge, when it comes from infinity to this point, the work done will be stored as potential energy. Mass comes, gravitational potential energy. Charge comes from infinity, doing work will be stored as electric potential energy. Molecule is going to the surface, from the bulk to the surface will be stored as surface energy. But that work done will be converted into surface energy. Okay, note it down. So whatever points I said, okay, in the way you understand, note it down. Okay, clear? So all the molecules inside water will be in continuous microscopic. Will these molecules with such high energy, will it be happy? Happier, Guma? More energy. Definitely they don't want to continue like that. So the thing is, more surface area, more surface energy. Allava? Correct or what? If we extend this surface area, what will happen? Again all the molecules will try to go there, right? Okay, so more surface area, more surface energy. So in order to reduce that surface energy, it will try to decrease the area. Okay, so liquid takes minimal area just because of this reason also. So surface tension and surface energy, all these are associated. Clear or what? More surface area, more surface energy. Okay, more energy is not preferred. More energy is not preferred, that too a kind of potential energy. So they don't prefer this. So in order to reduce the energy, it will reduce the area. Bas. Okay, suppose if we have a film like this, okay, if we have a film like this, Now this length is L, this length is X. Suppose if we are applying an external force, and we increased the area here to here, correct or what? This. So work done by external agent is equal to what? F external dot, what is the displacement? Delta X. So F external, so what is work? F dot S, Fs cos theta. So F external into delta X into cos 0. Force is in this direction, this displacement S is equal to delta X is also in this direction, theta is equal to 0. Okay, so I could write F external delta X. How much external force I should apply? I should apply external force equal to the force due to surface tension. A external force extra compared to the force due to surface tension, correct? Okay, surface tension is kept the film like this. So on the side, when I try to pull, I should apply a little bit extra, then only this film will come to this side. That extra, a little, we are neglecting. That is only while starting. After that it will come. Okay, so this F external will be equal to what? Surface tension into L. If this is the line, definitely what will happen? That side will be the thing, correct or what? Okay, so this is going to be how much? Surface tension into length. Now if we put work is equal to F external, then surface tension into length into delta X, we can write this L into this delta X is nothing but the extra area. This is the extra area. Correct or what? Extra. How much is the extra area? L into delta X. So work is actually surface tension into change in area. Clear? Fine. Okay, so another surface energy. Okay, so surface energy is equal to what? Surface tension into change in area. Clear? Okay, any objection? Is it correct? Is it correct? This change in area, is it correct, children? Actually, change in area, what also will come? This is a soft film. So when we increase, what also will come? This extra change in area, what also we can put here? 2. And here also I should put what? 2. So change in area, when I say Directly I could say change in area, but that change in area you should consider, if it is film, then two sides will be there. If it is drop, only one side. Okay, based on that. Soap bubble, increase in the area of soap bubble, we should consider twice the area. Okay, so generally study this as in this way. Surface energy is surface tension into change in area. Change in area we should apply sense. Okay, clear? Okay, so simple problem we will do, then we will get into more things. Okay. Okay, so surface energy is equal to surface tension into change in area. So surface tension either T or S, anything can be used. So energy is equal to surface energy, suppose if we put it as U. Okay, surface energy if we put it as U. Okay, this is equal to surface tension S into change in area. Sometimes surface tension we call T also. Okay, into change in area. Clear? What is the work done in increasing this area? So this was the dimension of soft film is 10 centimeter. This side it is 1 centimeter. Okay, x is equal to 1 centimeter is equal to 10 centimeter. 1 centimeter. What will be the work done in increasing that area? Zero? 0.8 into minus 6 minus 4 Newton தானே ஜூலா நியூட்டன் per மீட்டர்ல ஓகே ரொம்ப ஓவரா பேசுறீங்கல்ல okay so work done is equal to what? Surface tension into change in area. Surface tension is 0.04. Change in area is how much? This is the change in area on one side. So this width is actually 1 centimeter. This is 10 centimeter. So we can change in area is nothing but 2 into soft film India. So this is soft film. So 2 into 10 into 10 raised to minus 2 into 1 into 10 raised to minus 2. Clear or what? So this is going to be 0.08 into 10 raised to minus 3 left minus 3. So 8 into 10 raised to minus 5. Correct? Correct? Done? Okay, so what is the surface energy in this case? In this new case, what is the energy stored or energy or surface energy? Same. Okay, whether it can be asked as work done or it can be asked as surface energy also. Okay, clear? Another thing is a soap bubble, its radius is 2 centimeter, to a soap bubble where the radius is 5 centimeter. How much should be the energy or work done? Surface tension of soap bubble of soap, okay, is given as S is equal to 0.03 Newton per meter. Say the answer in with including pi. No need to. Just tell the answer in terms of pi. Other answer already if you have worked out, tell me. No worries. 198
into 10 raised to minus 6.
198 into 10 to the power of minus 6 joules. Anyone else is getting the answer? Aslam avargale, are you getting the same answer? Okay, so this one, the change in surface energy, okay, already surface energy is there. What we are finding out? Change in surface energy, okay, change in surface energy. Already when you change the area, that is nothing but change in surface energy. Clear? So this is equal to what? Surface tension into the change in area. So what is the area of sphere? 4 pi r square. So 4 pi r square minus 4 pi r square. This is the change in area, right? This is the change in area. So this is soap bubble. Two surfaces will be there. So can I ask 2 here? Right. So this is going to be T into 4 pi into 2, and here it comes r square minus r square. Done. So 0.03 into 4 pi into 2 into, that is going to be, here we will take that r square into 10 raised to minus 4 we will take out, and this is going to be how much? 5 square is 25. This is going to be 4, correct or what? Okay, so this is going to be what? 8 24. How much?
24 pi into 10 power minus 6.
24 pi into 21. So when we do this, how much we are getting? 1584 into 10 power minus 6. Mostly this will come only 24 into 21 only we may have to do. This pi will be there in the option. Okay, clear? Are you all getting this answer? Right? Done. Okay, so now shall I erase this? Done, all of you? Suppose if we take a big charge, and if you make it into 100 or 1000 small charges, okay, charge will be equal, no? Both the sides charge will be equal. What will change? Area will change, then potential. So whatever we are studying in the other chapters now, same kind of questions, if possible, they will apply in this chapter also. Understood or what? So once if you are studying one approach and concept, the same thing can be applied here. Okay, just like from gravitation, electrostatics, moving charges. If you compare and study, most of the things are same. Just gravitation is light one. That's it. Remaining all the concepts are same, no? Okay. So same way here also we will have a question where one liquid drop, large liquid drop, okay, large liquid drop will make it into smaller drops. Okay, like this. So let this be 1000 identical drops. Okay, 1000 identical drops. Suppose this one's radius is 10 raised to minus 6. Here the surface tension is 0.07 Newton per meter, and here we are going to have small r, 1000 identical drops. What is the change in surface energy? What is the change in surface energy? What is the change in surface energy? This is the question. Okay, clear? So how to approach this problem? Volume will be same, no? Volume will be same. Okay, if you put this large drop inside one beaker, and if you put everything in another beaker, volume will be same water amount, correct or what? Only area is changing, So one thing which you could say is 4 by 3 pi r cube will be equal to 1000 into 4 by 3 pi r cube. So this is of bigger one, and this is 1000 small ones. Okay, so this is volume are equal. So 4 by 3 pi, if we cancel, r cube is going to be 1000 r cube, correct? So if we take the cube root of this full thing, what will happen? R is equal to 10r. So small radius is going to be capital R divided by 10. Capital R divided by 10. Correct or what? Okay, so what is now the change in area? This is actually water drops. We need not worry about making it twice. Correct? No need to take twice. This is water drop. So change in surface energy is going to be surface tension into 4 pi. Which one will have large area, children? This one will have large area. This one will have larger area compared to this one, because here this is a sphere, it will try to reduce it into minimum area, but this one, each one will be trying to minimum area, but overall here the area will be more. Surface area will be more, no? Area means surface area. Here more surface will be exposed. Correct or what? If we measure each one, and if we measure each one, then it will not be equal. So here 4 pi r square. 4 pi r square, how many? 1000 into 4 pi r square minus 4 pi r square. Correct or what? The change in surface energy is surface tension into change in the area, change in the surface area. Clear or what? Okay. Now we have got capital R as, capital R is 10 raised to minus 6. Then small r will be how much? 10 raised to minus 6 divided by 10. So this is going to be how much? 10 raised to minus 7. 10 raised to minus 7. Correct or what? Any confusion? Any doubt? Anyone? Look at the solution. If you have any doubt, please ask. So this is going to be, surface tension is given as 0.07 into 4 pi if I take outside. Inside this is going to be 1000 into r square. So small r is going to be 10 raised to minus 7. So r square means 10 raised to minus 14. Correct? Minus this r square is how much? 10 raised to minus 6. So this is going to be 10 raised to minus 12. 10 raised to minus 12. Correct or what? So simplifying this, we'll be getting some answer. Okay. Around 8 into 10 raised to minus 12. Okay. 8 into 10 raised to minus 12 joules is the change in the surface energy. Clear, children? Okay. Fine. How much time it will take if you do like this? Okay, shall I raise this? Completed? Completed. So we will make this, we will make a summary for this problem. Okay. Whatever way they ask, if they split bigger drop into smaller drop, how we should deal them. Okay. So without wasting much time, we should be able to do this problem. So right from the beginning, how I explained, I shall explain once again, and I will give you this last formula we have done. No, this last formula we have written. Okay, so this one, what is this 1000? N. So this is N. So 4 pi if we take outside, surface tension into 4 pi into N into small r square minus capital R square. So likewise we will make it into a formula. 2 will not come by, because this is drop. Water drop means only outer surface is in touch with the air. Inner there is no surface. It is just like this. Water drop means inner it is full of water, inside it is full of water. So we will get a surface here. Inside we will get a surface. So just to understand that what surface is in touch with air, that can be considered as a surface.
If it is a water bubble, then
if it is a bubble, it will be like this. Outer also air, inner also going to be air. So this is one surface and this is another surface. Likewise. Clear? Okay. So splitting of big drop into smaller drops. Splitting of big drops into smaller drops. So first thing is, its volume 4 by 3 pi r cube will be equal to, how many numbers are given? Okay, that n into 4 by 3 pi r cube. Correct or what? Volume will be same. So from this, cancelling that, we will be able to write n r cube will be equal to r cube. Or I could say n raised to 1 by 3. N raised to 1, take the cube root, this into r is equal to r, or I can say smaller r is going to be capital R divided by cube root of n. Cube root of n. Clear? Right? Now, initial area is 4 pi r square. Initial area. Final area is going to be 4 pi r square. Correct or what? 4 pi r square. Now, fine. Initial energy. Initial surface energy Ui is nothing but surface tension into this area. So, initial surface energy is T into 4 pi r square. Final surface energy is equal to T into 4 pi small r square. Correct or what? Okay, so we will list everything. Now, change in area is equal to what? Change in area here, n into 4 pi r square minus 4 pi r square. Correct or what? So if we write, this is going to be n into 4 pi into r square minus r square. Correct or what? This is the nr square minus square. So this is the change in surface area, each one. Okay, just to have better clarity. Okay, children. Now, usually we haven't covered thermal properties of matter, because in the order also that will come next. But when we attend JEE or Neet, they are under the impression that we have covered everything. Correct or what? So thermal properties of matter can come here, elasticity also can come here, anywhere anything can be come. So children, when you give energy to a system, its temperature will increase or decrease? Increase. Here, if the energy, if we increase the energy, when we increase the surface energy, what will happen? Temperature increases. Nice example I shall tell you. If you take a sprayer, take lukewarm water, not boiling water, take very simple warm water, see the temperature. Now you spray it, you will be getting cold water. Here surface area was less. When you are spraying this one mortar, big drop water, this is converted into small, cute, sweet water drops. If you are spraying. So that is the reason, even if using mortar, if they are doing that sprinkling in the gardens, you go and touch that water, it will be colder than the water in the well or in the tank. So when you are spraying, you will be getting cold water. What is happening? Temperature is decreasing. So what we must understand is, this surface they are not taking from outside. This surface energy they are taking from the system itself. From the system they are taking the surface energy. Okay, so generally everything will have, the temperature is completely associated with what energy? Kinetic energy or potential energy? Kinetic energy. Correct or what? Why when you dip your finger in a hot water, you feel burning sensation, right? If temperature is more, temperature is less, why should we get burning sensations? If temperature is more, okay. Temperature is less, okay. Only that sense need to come. Why we are getting that problem? Why it is affecting our skin? Why? Because if the temperature is less, okay, Madhumati molecule, okay, molecule's name is Madhumati, Madhumati will be moving like this if the temperature is less. Okay, now if we are increasing the temperature, Madhumati molecule will be start moving very fast. Correct or what? Increasing the kinetic energy. Okay, so when we increase the temperature, kinetic energy will increase. Okay, so kinetic energy will be there. So all these molecules I said, they are in continuous motion, right? The electrons, okay, molecules, all of them are in motion. In gas, the movement is much more. In water, again, movement is there. Even in solid also, some vibrational movements will be there. Okay, so anything, whatever it may be, everything is in motion. So definitely a system will have some kinetic energy. Nitish Tangam, are you able to follow? Okay, anything will have some kinetic energy. So when this surface energy is made, when you increase the surface area, who will give energy? No one will give. All are confused. No one will give any energy. I won't give. Only if there is any thermal difference, that will happen. Otherwise, no one will give. Okay, so what they will do, in order to increase Mudiyama without no other way, when we increase the surface area, what will happen? It will take the energy from inside. So what will happen? Kinetic energy will be affected. Kinetic energy will be affected. Surface energy will be increased. Kinetic energy will come down. Surface energy will increase. Conservation of energy. Conservation of energy. So what will happen? Temperature will come down. Temperature will come down. So we will come to that temperature also later. Now this is what is the difference in area. So the difference in surface energy will be what? 4 pi. What we should add? T. T into nr square minus r square. Okay, so this is the basic formula. Nr square minus r square. Now see, look at this. N raised to 1 by 3 into small r is equal to capital R. Small r is equal to capital R by n raised to 1 by 3. So here this is one formula. Another formula is delta U is equal to 4 pi T R square when I take it out. Here nr square by r square will come. Nr square by r square will come. Here minus 1 will come. For this r square, I will be substituting n raised to 1 by 3 into r there, and I will modify accordingly. So final formula will come in this way. Okay, so this is going to be n raised to 1 by 3 minus 1. So this is second formula. How this I am getting? I will be taking this r square outside, then this is going to be nr square by capital R square. So there capital R is equal to n raised to 1 by 3 into r. I will square this, I will substitute here, I will cancel, and I will modify. Okay, so if you have doubt, you go to home and try to derive this. Okay, so this is the first formula, second formula, third formula of this one. Okay, change in surface energy is equal to 4 pi r square into t, right? So final one, r by r minus 1, third one. Okay, fourth formula is change in surface energy is equal to 4 pi r cube into t 1 by r minus 1 by r. So based on the situation, you can use any formula for finding the change in surface energy. For finding the change in surface energy. Clear?
U final into system
ഇല്ല. ഈ this n term we are replacing with r and r. ഇവിടെയാ. Yes. Okay, correct. Okay, so energy will be absorbed. Energy will be absorbed for the terminology is like, have you all noted down, completed? Shall I erase this? Okay. So here energy is absorbed. Energy is absorbed. So when you read that, you should not get confused. Energy absorbed means temperature should increase. So here we say energy is absorbed. And temperature decreases. Temperature decreases. So temperature, why it is decreasing? Because this energy is absorbed from the system itself. So energy is absorbed from the system itself. So we will have to understand that temperature will be decreasing. Clear or what? Okay. So here the change in surface energy 4 by 3 pi r cube T, and 1 by r minus 1 by r. This is also one formula, right? Okay, correct or what? This is one formula. Among all those four formulas, this is also one formula, correct? Work done or the change in surface energy. Change in surface energy. Okay, right. Okay, children. Now see. Suppose if the temperature decreases, m mass of liquid, S is specific heat capacity of liquid. Delta theta is the change in temperature. Okay, so 5 gram of water was there, 5 gram drop was there, its surface area is changed. 5 gram of water was actually a bigger drop. We converted this into 1000 small drops. Again here also 5 gram, here also 5 gram. So its surface area is completely changed. So what will happen? Its kinetic energy is converted into surface energy. So how much energy will be used? ms delta theta. So the energy used will be ms delta theta. How many of you do not know about this? Just raise your hands without any worry. Suttama idea illa. Okay, so this is nothing but, see children, specific heat capacity means for 1 gram of a material to change its temperature by 1 degree Celsius, how much energy is required? That is what is called specific heat capacity. Suppose if I am taking 1 gram of water, I need to change. Already the temperature is 10 degrees Celsius. So that 1 gram of water I need to convert into 11 degrees Celsius. How much energy is required? That is specific heat capacity. So overall if I say instead of 1 gram, so see, for 1 gram, for 1 degree change in temperature, for 1 degree change in temperature, how much energy is required? Specific heat capacity, S. So instead of 1 gram, if I am making m gram, then correct or what? For 1 gram, S. For m gram, m into S. 1 gram ku vandu 2 joules nu vechunga. So for 10 gram ku into 10. 1 gram ku 2 joule na 10 gram ku 20 joule. 1 degree Celsius change. For 1 degree Celsius change, this is S. Now suppose for 10 degree Celsius change into 10. So for m gram, for delta theta means change in temperature. Instead of delta T, we are using delta theta for our convenience. Okay, delta theta. So delta theta is nothing but change in temperature, 10 degrees Celsius to 20 degrees Celsius. Change in temperature is 10 degrees Celsius. 10 degrees Celsius is 100 akono. Change in temperature is how much? 90 degrees Celsius. So this change in temperature is 90 degrees Celsius. So how much energy will be required for m gram? Ms delta theta. Clear or what? So that is what I have written here. So the heat required to change the temperature of something, whether increase pannanalum, decrease pannanum, okay, either to increase or decrease, this much energy is required. This is mass, this is specific heat capacity, this is the change in temperature. Specific heat capacity is different for different material. For water it is different, for ice it is different, for steam it is different, for copper it is different. Depends on the material. Okay, if we give from outside, if your Hemant, Uday, so Uday is a system. I am taking q gram of energy I put on Uday. So what happens? His temperature will increase. So I took the specific heat capacity of Uday, 4. Okay, 4. Okay, so mass of Uday, 50 kilo. Sorry, 40 kilo. Okay, so 40 kg is the mass. Okay, specific heat capacity 4. I need to increase his temperature by 1 degree Celsius. Why to worry him too much? So MC delta theta, when I am doing 40 into 4, 160 joule. After that, if I put the temperature, I am able to see 1 degree rise in temperature. Children understood? Now I took the heat and I gave to him, his temperature increased. Now what I am doing? I am taking heat from him. Now his temperature will decrease. Understood or what? When I give heat, temperature will increase. When I take heat, temperature will decrease. So when it or decrease, it is based on whether giving or taking. Quantity, formula, everything will be same. Clear or what? So energy is absorbed, temperature decreases. So how much energy will be absorbed from the kinetic energy part? Ms delta theta. Make sure you put this in joule, kilogram, Kelvin, and the specific heat capacity also you should write in joule per kilogram degree Celsius. That's it. Okay, children, so this is all about splitting of the drop. Okay, completely go through this formula and please understand the thing so that you will be able to deal the situations in a better way. Clear or what? Done. So now I shall ask you 3 cases. The work done in the formation of bubble, work done in the formation of increasing the bubble size into double size, then likewise I shall ask you certain questions. Okay, try to write it. Okay children, okay fine. So first then the work done in the formation of a drop of radius r. Okay, work done in the formation of drop of radius r. Okay, how much will come? Suppose if the surface tension is T or S, what is the area of the drop? We can consider the initial energy is 0. This was nothing. Now we are making a drop. So what is the surface area? 4 pi r square into surface tension. Clear? Done? That's it. Okay? One point. Another point. Work done in blowing a soap bubble of radius r. Work done in a soap bubble of radius r. 4 pi r square will be the outer area. Inner area also will be same, no? So this is going to be 2. So 8 pi r square into t. Okay, so 2 surfaces. Okay, now another question. Work done in blowing a soap bubble of radius r1 to radius r2. Pi r1 up to 4 pi r2 square t minus 4 pi r1 square into t into 2. So overall we can write in this way: 8 pi t into the difference is going to make in the radius r2 square minus r1 square. Comfortable? Okay, done. Okay children, okay, shall we do some questions, then we will move to capillary action, and that will be easy. Okay, done. Okay, okay, a paper disc of radius capital R. Okay, question is paper disc radius capital R, which from which a hole is cut out. a hole is cut out. That is, this is a disc, a hole is cut out, this radius is capital R, this is a hole. Okay, so this is a paper disc. This one's radius, this hole's radius is small r. Clear or what? Okay, so its surface tension, the surface tension of the fluid which is kept, this disc is kept, is T. What will be the force due to surface tension? Okay, force on disc due to surface tension. So force is going to be 2 pi r into T plus 2 pi capital R into T bus. So 2 pi T into R plus R. Clear? Very easy. Comfortable? Right. Okay. Another question is, okay, so this is a soft film. Okay, soft film. Okay, and we can say this is PQRS. This is a soft film. This is PQRS. This side is movable side. This is movable side. Clear? Okay, the question, surface tension of the soap solution. Surface tension of the soap solution is given as 0.045. 0.045 Newton per meter. Okay, so what we need to find is the diameter of the wire to maintain equilibrium. Diameter of the wire to maintain equilibrium. Diameter of the wire to maintain equilibrium. So the wire is actually a copper wire. This wire is a copper wire. This is another information. This is a copper wire. Its density is also given, which is nothing but 8.96 into 10 raised to 3. 8.96 into 10 raised to 3 kilogram per meter cube. Clear? Now we need to find the diameter of the wire. Okay, see, if you are moving on the right track, I mean solving this question, if you are on the right track, you will be getting an answer in root. So you need not take the root of that, it is not easy. So simply your answer should be root of 2.95 something or root of 10 point something, likewise. Clear? Shall I do, children? Shall I do? Anyone is getting the answer? Do you, anyone wants to share the idea how you are doing? sir, this is surface tension into that will be equal to this thing, that is how I am proceeding. Do you want to share like that? What? Discussion should be there in the class. Okay. See, this side what will be there? Surface tension. So surface tension into this length, correct? This length. 2 into surface tension into this length. Clear? mg. Okay. So that is correct. So 2TL is equal to mg. Okay. Now 2TL is equal to what they are asking? Diameter. So we will break this mass. We won't be able to do anything on G. So what we can do? Volume of the wire into density of the wire. Density of the wire is also given. So volume is nothing but area into length. So area is pi r square, correct? Pi r square into rho into what is that length? This length is L allava. This length is L. So pi r square into L. Volume is done. This is going to be density. This is going to be G. So 2 into T into L is on the other side. No, we need not think like the L is not given. How I am gonna find down. Okay, find it down. There's no need to think like that. Put it on the pen and paper so that we will be able to recognize how many things will be cancelled off. So L and L has gone. One need to find R square. So R is equal to 2T divided by what? Pi rho G root. Understood or what? Okay, so if these kind of questions will come in the exam, how I am going to deal this? No need to think like that. Already you have done, no? If this question comes in the exam, definitely you will do because you know this now. So as many questions as possible, if you do that situation, you can reduce to the minimum. So this is the formula for this situation. You can note it down. Okay, you can note it down. Clear or what? So the answer is going to be R is equal to, so diameter is equal to 2 into root of 2 into surface tension is going to be 0.045 divided by pi into density of copper is given as 8.96 into 10 raised to 3 into here it is 10. So if you simplify, you will be getting the answer. So put it in root itself.